Liquid cooling is technically superior to air cooling by every measurable engineering metric. The data is not ambiguous. Water-based coolant absorbs 3.4 times more heat per kilogram than engine oil. Compared to air, coolant carries approximately 4,000 times more heat per unit of volume. A liquid-cooled engine maintains its operating temperature within a 5 to 8 degree window. An air-cooled engine's cylinder temperature can swing 50 to 100 degrees Fahrenheit based on nothing more than whether you are moving through traffic or sitting in it. Higher compression ratios are possible with liquid cooling, more power per cubic centimeter, lower emissions, more consistent combustion, better fuel economy. The BMW R1200 GS went from 110 horsepower to 125 horsepower, a 14% gain when BMW added partial liquid cooling to the same 1,170 cubic centimeters displacement. The Harley Revolution Max produces 150 horsepower from 1,250 cubic centimeters. The air-cooled Milwaukee-Eight produces 105 horsepower from 1,923 cubic centimeters. Act 1. The physics, why liquid cooling wins technically. When an engine burns fuel, approximately 30% of that energy moves the motorcycle forward. The remaining 70% becomes heat. Managing that heat is not optional. If it is not removed, pistons expand, oil breaks down, and the engine seizes. Air cooling is the simplest possible solution. Metal fins machined into the cylinder increase the surface area exposed to airflow. The more surface area, the more heat the passing air can carry away. The physics are straightforward. Convection transfers heat from the hot metal surface to the cooler air flowing over it. The limitation is equally straightforward. Air cooling requires airflow. A motorcycle moving at a highway speed has continuous high-velocity airflow over the cylinders. That same motorcycle sitting in summer traffic in Phoenix has almost none. Cylinder temperatures in those conditions can swing dramatically, 50 to 100 degrees Fahrenheit, in a matter of minutes. That temperature instability has direct consequences. Engineers designing an air-cooled engine must account for the worst-case temperature scenario. Compression ratios must be conservative enough to avoid detonation when the engine is running hot. Air-cooled motorcycle engines typically max out at 9 to 1 to 10 to 1 compression. Liquid-cooled engines routinely run 12 to 1 to 13 to 1. The compression ratio is where the power lives. Higher compression equals more power from the same displacement. The BMW numbers make this visible. 110 horsepower to 125 horsepower from the same 1,170 cubic centimeters from adding partial liquid cooling. The same mechanism that controlled the temperature allowed the engineers to push the compression ratio higher and extract more from the same physical engine. Oil cooling sits between the two systems. Engine oil already circulates through the engine for lubrication. An oil cooler, a small radiator mounted at the front of the machine, routes the oil through an external cooling circuit where airflow reduces its temperature before it re-enters the engine. Oil reaches internal hot spots that cylinder fins cannot, the piston undersides, the valve train, the combustion chamber adjacent surfaces. But oil's heat-carrying capacity is limited compared to water-based coolant, and like air cooling, oil cooling still depends on airflow past the cooler. Stop in traffic and oil cooling efficiency drops with the airflow. Liquid cooling solves both problems simultaneously. The thermostat blocks coolant flow during cold starts, allowing the engine to reach operating temperature faster, which matters for emissions because catalytic converters need heat to function. Once at operating temperature, the thermostat opens, coolant circulates through the radiator, and a fan provides forced cooling when the bike is stationary. The engine operates within a controlled temperature band regardless of riding conditions. Emissions is where the regulatory pressure comes in, but that story belongs later. First, the story of why air cooling has survived technically inferior status for 100 years. Act 2, the $900 motorcycle and what it tells you about engineering priorities. India is the largest motorcycle market on Earth. Over 20 million two-wheelers are sold there every year. The best-selling motorcycle in that entire market is the Hero Splendor Plus. It starts under $900. It runs a 97cc air-cooled engine. It has been India's best-selling vehicle, not just motorcycle, vehicle, for years. Adding a liquid cooling system to the Hero Splendor Plus would cost between $500 and $1,000 in manufacturing cost. On a $900 motorcycle, that is a price increase of 55 to 111%. That is commercial suicide for the manufacturer that serves a market where the motorcycle is not a leisure product, but primary family transportation. But the economics go deeper than sticker price. In rural India, where two-wheelers represent approximately 75% of all registered vehicles, the roadside mechanic is the service infrastructure. He works with hand tools. He knows air-cooled engines from decades of working on the same basic designs. He can diagnose problems by sound and feel and fix them with what he has available. A liquid cooling system requires coolant that may not be available in a small village. It requires knowledge of thermostat function and water pump diagnosis. It requires pressure testing capability to find slow leaks. If a liquid-cooled radiator cracks on a remote road in Rajasthan, the rider has a problem that no amount of local mechanical knowledge may resolve. The air-cooled engine that breaks on the same road can very likely be repaired by someone nearby. This is the same principle documented in the African mechanics context. The machines that survive in resource-constrained environments are the machines that's simple enough to be understood and maintained without a dealer infrastructure. The Hero Splendor is not air-cooled because liquid cooling is unavailable. It is air-cooled because liquid cooling is inappropriate for the conditions its riders actually live in. Royal Enfield understood this. Their entire lineup was air-cooled and oil-cooled for decades before introducing the first liquid-cooled engine, the Sherpa 450 and the new Himalayan in 2023. Even their 650cc twins still use a conservative 9.5:1 compression ratio, which improves durability and tolerates the variable fuel quality present across India's diverse distribution network. The compression ratio is a deliberate engineering choice that reflects the riding context, not a limitation the engineers could not overcome. Western motorcycle press coverage of Indian and developing world machines has consistently treated these decisions as evidence of technological backwardness. They are actually evidence of engineering appropriateness. Designing a motorcycle for its actual operating context rather than for a laboratory metric is not primitive engineering. It is honest engineering. Act 3. The Spitfire Connection. How a World War II aircraft engine changed motorcycle cooling. In the early 1980s, a Suzuki engineer named Etsuo Yokuchi was studying two engines. One was the Rolls-Royce Merlin, the piston engine that powered the Supermarine Spitfire fighter aircraft during the Second World War. The other was the Cosworth DFV Formula One engine. Both engines used a technique where high-volume oil was sprayed under the pistons to carry heat away from the hottest internal surfaces, surfaces that exterior air cooling or conventional lubrication circulation could not reach effectively. Yokuchi adapted this concept into what Suzuki called SAX, the Suzuki Advanced Cooling System. SAX used a double-chamber oil pump. One side handled normal lubrication at high pressure. The other side circulated a high volume of oil at lower pressure through dedicated passages in the cylinder head and sprayed it directly onto the underside of the pistons. The result was that engine oil temperature stabilized around 100 degrees Celsius and never exceeded 135 degrees, a 15-degree reduction compared to pure air cooling, achieved without adding a radiator, water pump, coolant, or any of the weight and complexity of a full liquid cooling system. The first motorcycle to use SAX was the 1985 GSX R750. It was 68 pounds lighter than the bike it replaced while producing 16 more horsepower. That machine changed the direction of sport bike design. The idea that you could achieve meaningful thermal improvement without the weight penalty of full liquid cooling, derived from a fighter plane engine built 40 years earlier, transformed what was possible in the performance category. Suzuki used SAX across their lineup for over 2 decades. The principle lives on in Bajaj's oil-cooled engines, in Royal Enfield's cooling approach on the 350 and 650 Classics, and in Harley-Davidson's precision oil cooling on the Milwaukee-Eight. The engineering genealogy runs from a World War II Spitfire to the Harley you see parked outside a diner in 2026. The cooling system on the motorcycle you're considering buying directly affects 2 numbers that the dealer will not put in front of you: the recurring maintenance cost and the long-term reliability record. The 2026 Motorcycle Buyer's Bible documents both. Section 2 covers the OEM tire situation. The tires on your new motorcycle wear 30 to 50% faster than the retail version of the same tire. The cooling system maintenance costs, coolant flush intervals, water pump service life, hose degradation timelines for liquid-cooled machines versus the simplified maintenance of well-designed air-cooled platforms are in Section 7's maintenance schedule with actual cost comparisons, was $97. Now $9, link in the description. Act 4, the Harley Culture War. Harley-Davidson's relationship with liquid cooling is one of the most documented cases of engineering capability being overridden by cultural identity in manufacturing history. For decades, the exposed cooling fins on a Harley V-twin were not a technical feature. They were an aesthetic identity. The fins were the look. They were part of what a Harley-Davidson was supposed to be: visible, mechanical, honest about its own engineering in the way that a machine with its working parts exposed is honest. You could look at a Harley and understand how it cooled itself. The fins told you. When Harley launched the V-Rod in 2001, their first liquid-cooled engine, developed in collaboration with Porsche engineering, the response from the Harley community was explicitly negative. A Harley with a radiator was described by multiple vocal segments of the ownership community as a fundamental departure from what Harley was. The V-Rod attracted new buyers and sold reasonably well internationally. It was never embraced as a core Harley the way the Softail and touring bikes were. It was discontinued in 2017 after 16 model years. What Harley did next revealed exactly how much they understood about the cultural constraint they were operating within. The Milwaukee-Eight engine introduced in 2017, which replaced the twin cam across the entire lineup, used what Harley called precision oil cooling for the base models. The touring bikes that most needed better heat management in urban traffic received something more interesting: small liquid cooling radiators hidden inside the lower fairing panels where riders could not see them. The engine still looked completely air-cooled from the outside. The iconic fins were fully visible. The identity was preserved. The thermal performance was improved. Today, Harley's main touring lineup uses liquid-cooled Milwaukee-Eight applications hidden behind the visual language of air cooling. The Revolution Max in the Bronx, Pan America, and Sportster S is full liquid cooling with no heritage disguise, 150 horsepower, 13:1 compression, 9,500 RPM redline. But Harley put the Revolution Max in new model lines rather than replacing the classic touring bikes that their core demographic had been riding for decades. The engineering decision and the cultural decision are inseparable. Harley understood that changing what the bike looked like would change what the bike was to the people who defined the brand's survival. The radiator hidden inside the fairing lower is not deception. It is the specific compromise that allowed better engineering without destroying the cultural identity that made the engineering worth funding. BMW made similar choices more explicitly. Their flat twin boxer engine has been in continuous production since 1923. The progression moved from pure air cooling through oil cooling to partial liquid cooling to full liquid cooling over 80 years. Then in 2020, right in the middle of that march toward greater liquid cooling sophistication, BMW launched the R18, a brand new motorcycle with a deliberately air and oil cooled 1,802 cubic centimeters boxer engine. This was not a legacy machine. This was a new platform. BMW chose air cooling for the R18 as an active product strategy statement about heritage and identity at a moment when they possessed the full engineering capability to make it something else. They chose to make it this because air cooling was the right answer for what the R18 was supposed to be, not because it was the only answer available. Act 5, the regulation that is ending the debate. The cultural battle over air cooling may eventually become irrelevant, not because engineering resolved it, because government did. Euro 5 motorcycle emission standards, which took effect in Europe between 2020 and 2021, set limits that the European Motorcycle Manufacturers Association confirmed match Euro 6 standards for cars on key pollutants. The hydrocarbon limit represents a 41% reduction from the previous Euro 4 standards. Air-cooled engines face two specific structural disadvantages under these standards. The first is cold start emissions. Without a thermostat, an air-cooled engine begins cooling the moment the motorcycle moves. The engine takes longer to reach operating temperature. During that extended warm-up period, the catalytic converter, which requires heat to function, is sitting idle while unburned hydrocarbons pass through the exhaust. A liquid-cooled engine with a thermostat blocking coolant flow during cold start warms up faster, gets the catalyst working sooner, and produces lower cold start emissions. The second is NOx formation. Nitrogen oxide production increases exponentially with combustion temperature. Air-cooled engines running at higher and less controlled temperatures produce more NOx. Liquid cooling's ability to maintain consistent operating temperatures allows engineers to run leaner fuel maps, which reduce NOx formation, without the risk of detonation from uncontrolled hotspots. The casualties are already documented. The Yamaha XJR1300 was discontinued because meeting Euro 4 would have required detuning it beyond recognition. The Ducati Monster 797, the Kawasaki KLR 650, the Honda VFR 800 all required significant revision or discontinuation under successive emissions rounds. Euro 5 Plus, which arrived in 2024 and 2025, added onboard diagnostics requirements that pushed compliance costs higher still. Air-cooled engines can meet current standards. The BMW R9T, Ducati Scrambler 800, and Royal Enfield 350 and 650 twins all comply. But each new round of standards increases the engineering investment required to maintain compliance, and manufacturers are doing the math on whether that investment is worth the sales volume of the remaining air-cooled platforms. The man who rode his air-cooled BMW R100 GS through Morocco and Mali in 40-degree heat with no problems, and then handed it to a new owner who topped 100,000 miles. That machine would not survive a 2026 European homologation process without significant revision. The machine that worked perfectly well for its purpose cannot be sold new in the market where most of its buyers live. Act 6. What the last air-cooled Porsche tells you about the future. In 1998, Porsche ended production of the 993, the last air-cooled 911. Purists called the water-cooled 996 that replaced it a betrayal. The 996 was by every engineering metric a better car, more power, better thermal control, lower emissions, more consistent performance. Today, a clean 993 turbo sells at auction for $500,000 or more. The 996 that was supposed to be better sells for under $30,000. That is not a story about engineering. It is a story about what happens when a technology becomes scarce. When the last air-cooled Porsche was still in production, it was a car. When it became the last air-cooled Porsche, it became a cultural artifact. The market assigned it a value that the engineering metrics could not explain. The comment on the most watched air cooling versus liquid cooling video on YouTube has 334 likes and says, "Swap the V-twin 90 degrees around the vertical axis and there will be no more thermal problem." And you get a Moto Guzzi. That is a writer who understands the engineering clearly enough to identify a specific solution and who loves the culture enough to express it as a joke about a brand. That combination, engineering literacy and cultural attachment, is the precise profile of the person who will pay a premium for an air-cooled machine as they become less available. I personally think the air-cooled motorcycle is not dying. It is transitioning into something the vinyl record became. Technically inferior, culturally irreplaceable, and increasingly valuable precisely because the world is moving on. The $900 Hero Splendor in Mumbai will run air-cooled for decades because the economics demand it and the culture requires it. The $40,000 Harley Road King will maintain the visual language of air cooling even when the engineering has moved past it. The BMW R18 will be sold at a premium as a heritage statement by a company that understands exactly what it is selling. The last air-cooled Harley touring bike, whenever that day arrives, will not be remembered as a technological defeat. It will be remembered the way the 93 is remembered now. The cooling system on any motorcycle you are evaluating, new or used, has specific inspection indicators that separate a well-maintained machine from one that has been run hard without appropriate service. Section 7 of the 2026 Motorcycle Buyer's Bible has the complete pre-purchase inspection checklist with specific cooling system checkpoints for both liquid-cooled and oil-cooled platforms. For used liquid-cooled machines specifically, coolant condition, water pump bearing play, thermostat function verification, and hose condition are the 4 inspection points that most buyers miss. Section 5 has the specific model year recommendations across every category. Was $97, now $9, link in the description. Act 7, the 3 forces that physics alone cannot overcome. The 2-wheel truth video that covers this topic, 158,000 views in 2 months, ends with the observation that 3 forces are keeping air cooling alive that engineering arguments alone cannot overcome. Cost, identity, heritage. These are not irrational forces. They are the forces that determine what products actually reach which riders in which markets. Cost is not irrational. A $500 liquid cooling system added to a $900 motorcycle is not a $500 improvement. It is a machine that no longer serves the market it was built for. The engineering that is better by a laboratory metric is not better for the rider who needs to afford the machine, maintain it without a dealer, and find parts in a village market. Identity is not irrational. The Harley rider who bought into the visual language of the exposed V-twin fins, who made financial and lifestyle decisions organized around that machine and that identity, is not wrong to resist a change that alters what the machine communicates about who he is. The identity is real even if the engineering preference it encodes is technically suboptimal. Heritage is not irrational. The BMW R18 customer who pays a premium for an air-cooled 1,802 cubic centimeters boxer in 2026 is making a specific and informed choice to own a machine whose character is inseparable from its cooling method: the sound, the heat, the way the engine responds at low revs. These are not defects. They are the character that the liquid-cooled alternative cannot replicate. The air-cooled engine is going out the way it came in, on its own terms. And in the garages and on the roads where it still makes sense, the rural roads of India, the Sunday morning highways of the American Midwest, the heritage touring market of Europe, it is not going quietly.